Today we are going to demonstrate the buoyant force. For the buoyant force, the equation from the book is say the buoyant force equals the weight of the water displaced by the objects. The equation looks like this. F, the buoyant force, equals to the density of the water times the displacement of the water times gravity. To demonstrate the buoyant force, today we are going to use egg and salt water. Our goal is trying to add salt into water to make the egg float. In the equation here, we try to make the force of the egg is equal to x weight, equal to the density of the water, salty water, times the displaced salty water, which equal to the volume of the egg times the gravity. And the egg transferred here, both sides, the gravity of both sides, and the volume of the egg, both sides can cross out. And we left the density of the egg equal to the density of the water, which means if the density of the egg and the density of the water, they are equal, or the salty water, they are equal, the egg will not sink. And we transfer the equation by the mass of the egg over the volume of the egg, get the density of the egg, and use the mass of the water over the volume of the water to get the density of the salty water. What we need to find is the mass of the salt we need to add in the water. And after the equation, we can get, from the equation tell us that the salt we need to add in the water is 4.4 grams.
Different guess.
So all you need is an interpreter to say,
This is not edifying to the church.
49.8.
not without an interpreter.
49.8. We're trying to get 4.4 grams of salt here. More. Way more than that. Well, you will take away some. Like that. Just a little bit more. There we go. Just a little bit more. A little bit more. Like that. Sweet. Perfect. Should be.
Because it's really hard to do a face. Because you have to discuss the gross face.
I don't get it.
Like that.
So type in egg on the reference for egg white. But that doesn't. Oh! Egg white consists primarily of about 90% water, into which is dissolved 10% proteins, including albumin, and proteins from globulin. So there is albumin, although.
Say 200. 200. Now put the egg in and see how many. Ooh, 250. It's probably 248 something.
Let's say 249. 49.
No, I think it's 48.
Whatever. 48. Okay. 248.
Yeah, okay.
Okay, so this is the data we got. First of all, we got the mass of the egg equal to 50.5 grams. And we got this equation. First of all, I want to introduce what's VW1 and VW2. VW1 is the water plus egg, which is that one. There's a cup, water, egg. And VW2 is just pure water, which is that one. And the volume of the egg is equal to VW1 minus VW2, we can see from here. And based on the equation, we got VE, which is the volume of the egg, is equal to 348 cubic centimeter minus 300 cubic centimeter, which is equal to 48 cubic centimeter. Okay, now the second part. We use the equation, the mass of the water is equal to the mass of the container plus the water minus the mass of the container. So MC plus W is the mass of the container plus water, which is like that, which is equal to 307.5 grams. And the mass of the container itself is equal to 101.5 grams. And for the experiment, we use the volume of the water as 200 milliliter, which is equal to 200 cubic centimeter.
In addition, in here, the mass of the water actually is the mass of this water, which we use in the experiment.
Y minus 3 equals X. And then for
Here's the egg. Here's the salty water. Right now, the density of the salty water is greater than the density of the egg. So the egg should float. It should.
Ah.
I guess that way.